want to show you two more examples of present value annuity just to give you some extra practice here to see more examples of how this is worked out and some different applications that we have for present value annuity and the different situations that it can be applied for. In this example, we have a state lottery commission that pays the winner of the $1 million lottery 20 installments of $50,000 per year. So 20 installments times 50,000 comes up to be $1 million. And so the question is, if they're making 20 installments right over 20 years, how much should they have at the beginning of those 20 years, right? If they were able to take their amount and put it into an account that earns interest, they don't really need to have $1 million, right? Because that initial investment that they have is going to grow since they're making payouts, 20 times over 20 years. So the question is, determine how much money the commission should have in that bank initially to guarantee the payments, assuming that the balance on deposit earns interest at the rate of 4% per year compounded yearly. Right? So how much would you have to have in a bank now in order to have $1 million over the course of 20 years? Right? All right, so this is a present value annuity, right? Because we want to use the money now and we're making payments on it later, right, over those 20 years. All right, so we've got the formula here. Let's remind ourselves of what that formula looks like again. And then we'll identify our variables, plug in our numbers, and then we can enter that into the calculator. So the capital R is how much our payments are. This one is $50,000. The small r is the interest rate, 4%. M is, it's compounded yearly, so M is just 1. And for how long? We've got 20 years that we're doing that for. So we've got 50,000 times 1 minus 1 plus 0.04 divided by 1 raised to the negative 1 times 20, that's just 20. All divided by 0.04 divided by 1. I really don't need the divided by 1. I'm putting that into the formula, but when I put that into the calculator, I'll just leave that as 0.04. All right, so we've got 50,000 times, with the open parentheses, 1 minus another open parentheses, 1 plus 0.04. Close that parentheses, raise it to the negative 20. Close that parentheses and divide by 0.04. I don't need the parentheses around this 0.04 since I'm just dividing by 1, right? So I'm just dividing by 0.04. All right, and that gives us a number of, let's see what that is. That's $679,516.32, right into the nearest cent. All right, so what is this telling us? This tells us how much the commission should have in a bank. All right, that will guarantee that they can cover that $1 million payment with 20 installments of $50,000 per year. Right, so letting that 679,000 number sit in the bank earning a 4% interest, that will grow to $1 million over that 20 installments. Okay, and that's the present value annuity. We've got one more example that we can take a look at. This one, we're going to purchase a car. Murphy's buying a car. After making a down payment of $6,000 for this car, He pays $600 per month for 36 months, that's 3 years, with interest being charged at a rate of 6% per year, compounded monthly on the unpaid balance. And we want to know two things. What was the original cost of the car? And what portion of Murphy's total car payments went towards interest charges? Okay, so this is a present value annuity. We're buying the car, right? So we borrow the money so that we can pay for the car. And now Murphy is paying the bank back $600 per month, right? So he uses the money now. He pays it back a little bit at a time over the course of 36 months. Okay, so we have the present value annuity. So we know we have this formula that we can use. Identify our variables. Monthly payment is $600. 6% interest, compounded monthly. And we're doing this over, I'm going to go ahead and write T as 3 years. All right, maybe in parentheses, I'll say that MT is 36 months. All right, be careful here because they're giving time to you in months. And so that 36 months, that is the number of payments, right? So if they give it to you in terms of the number of payments, that is M times T. All right, so we've got 600, plugging our numbers in, 600 times 1 minus 1 plus 0.06 divided by 12, raised to the negative 36 over 0.06 divided by 12. All right, so we will put this into the calculator just as we have been. 600 parentheses 1 minus second parentheses 1 plus 0.06 divided by 12. Close that inside parentheses and raise it to the negative 36. Close the opening parentheses and then divide it by 0.06 divided by 12. Remember the parentheses around that 0.06 divided by 12 in the denominator. And this gives us the present value annuity. $19,722.61, right? This is how much the loan is worth, right? This tells us how much Murphy had to borrow. Well, this tells us how much the cash value of this annuity was worth when he bought the car. So he made a down payment of $6,000 for the car. He borrowed $19,722.61. And so if you add those two together, or if you add the loan amount, let's say this is the loan amount, all right, and add the $6,000 down payment, that will give you how much the car was worth, how much he bought the car for. $25,722.61. That was the original cost of the car. Okay, so now the question is, how much of Murphy's total car payments went towards the interest charges? Right, so we need to determine how much went towards that loan amount and how much went towards the interest. Okay, so how much in payments did he make? Right, he paid $600 for 36 months. If you were to multiply that together, six hundred times 36, that's $21,600. All right, that's how much he made in payments. But now the loan amount was only $19,722.61. So if we subtract out the loan amount, the balance will tell us how much he paid in interest, right? So the total amount of payments minus the loan amount will equal the interest charges. So subtract the $19,722.61 to get the interest amount, which tells us that he paid $1,877.39 in interest. Okay, so the original cost of the car and the amount of interest that he paid.